Okay, here the recording in progress. So we'll go ahead and share the screen. Okay, so today I should be finishing up the ellipse, maybe sneaking a little bit of the hyperbola, but not much. So we probably will finish fairly early. All the rest of the days we'll probably finish fairly early. And the assignment again was changed to 1 to 27 odd. Okay, so here we are. We're doing the ellipse, and then we have the hyperbola left. Okay, the only thing we have left is quiz 11 and exam 6 on Thursday the 9th. Okay, which means Friday is just an office hour. You don't have to show up if you don't want to. And our final exam is Monday the 13th. So how do I study for the final exam? Just study the old exams. So just go back and look at the videos. I usually give them that weekend, right? So that would be Saturday the 4th for the solutions to exam 1, and Friday the 18th for exam 2, and Friday the 9th for exam 3, and so on. Okay, so just go back and review the exams. For the final exam, you can have 6 formula sheets, 6 cheat sheets. You can just save the ones that you had from before. Hopefully you didn't throw them away. But if you did throw them away, you can just make them again. No need to reinvent the wheel. Just bring all 6 formula sheets. If you want to add to it, you may. Okay, and again, it's starting time for the final exam. It's the first day of finals, Monday the 13th, 8:10 to 10:40. Use the same Zoom link as always. I'll set it so that 8 o'clock is fine. Okay, and I do have office hours Tuesday, Wednesday, Thursday during finals week, although it's not likely you would want to join because it's already after the fact, after the final exam's already been given. If you want to come, then let me know. It's a different Zoom link for that. Okay. All right, so let's try to knock off the rest of the ellipse problems as much as possible. Okay, so problem 17. So 17 foci are plus or minus 2, 0. Vertices plus or minus 3, 0. So here's plus or minus 2, 0, plus or minus 3, 0. That means we're centered at the origin, halfway between the two. And that tells me that A is 3, C is 2. So A is a distance from the center to either vertex. C is a distance from the center to either focus. So that's 2. Plug into A squared equals B squared plus C squared. A squared is 9. C squared is 4. B squared is 5. So B is radical 5, which is about 2.2. Okay. So 1, 2, 3 to the left and right. Up and down is 2.2. But I write it as 0 radical 5, 0 negative radical 5. So vertex 1, vertex 2, focus 1, focus 2. These are just the endpoints of the minor axis. There's no special name given to them, so just leave it. So my equation becomes x squared over 9 plus y squared over 5 equals 1. Okay. All right, then slightly harder problems. 21 was asked for yesterday. I have that here. 21. The length of the major axis is 5. The length of the minor axis is 3 in standard position with foci on the x-axis. Okay, so foci on the x-axis, that means we're bulging in that direction. Now, if the major axis is 5, A is 5 halves. The major axis is 2A. So this entire thing, that's halfway from the center each direction. So it's 2.5 to the left, 2.5 to the right. So that makes A equal to 5 halves. 2.5 that way, 2.5 that way makes a grand total of 5. Okay, so how do I know it's going this way? Because it says the foci are on the x-axis. That's the way that it's bulging. So it's not bulging vertically, but horizontally. Minor axis is 3. That's 2B. So B is 3 halves. So I go 1.5 up, 1.5 down, 0, comma, negative 3 halves, 0, comma, 3 halves. Okay, and all they ask for is the equation. So if all they ask for is the equation, I don't need to find the C. It's x squared over A squared. A squared, so 5 halves squared is 25 over 4. plus y squared over b squared. B squared is 9 over 4 equals 1. Okay, as far as I'm concerned, you can leave it like that. In the text, they simplified this by multiplying top and bottom by 4. And that becomes 4x squared over 25, I think it was. And that becomes 4y squared over 9, if you look at the way they wrote it in the back of the book. But as far as I'm concerned, it's easier to just leave it like this. Okay, because then you can look at this right away. That fits the form, right? It looks like x squared over a squared plus y squared over b squared equals 1. And then you can look at this and say, oh yeah, the square root is 5 over 2. That tells me how much I go left and right. And I can tell the square root of this is 3 over 2. That tells me how much I go up and down. Okay, so I'll show you that real quickly. 6.3, number 21, how they wrote it in the back of the book, which is actually not what I prefer in this particular case. Yeah, 6.321, 4x squared over 25 plus 4y squared over 9 equals 1. They just made it look a little nicer. If you multiply top and bottom by 4, which is allowed, then you have a 4 here and a 4 here. But this is actually better if you're working on this kind of stuff. All right, so we'll just leave the answer like that. Okay, then a couple of harder ellipse problems where we're not centered at the origin, but somewhere else. So 23, whoops, 23, foci 3010, vertex at the origin. So foci 3010. So halfway between the two foci is the center. So my center is 2, 0. So automatically I know I'm going to have x minus 2 squared over something plus y squared over something equals 1. So at this stage of the game, I already know this. Center at 2, 0 instead of 0, 0. So x gets replaced by x minus 2, shift 2 to the right. I have to figure out this stuff here. Okay, so I got a vertex at the origin. So this tells me A is 2. Okay. The distance from the center to either focus is 1. That's my C. So that means I know I'm going to put 4 here. 2 squared. X minus 2 squared over A squared. A squared, 2 squared is 4. And I just need to figure out the B squared. I know the C is 1. A squared equals B squared plus C squared. 4 equals B squared plus 1. Subtract 1. B squared is 3. B is radical 3. It's about 1.7. Okay, so that means I go 1.7 up and down. So the endpoints of the minor axis are 2 comma radical 3 and 2 comma negative radical 3. Okay, and by the way, that tells me the other vertex is at 4, 0. They give me a vertex at the origin. So it's 2 units this way, and 2 units this way would be 4, 0. Okay, so they already gave me the foci, 3, 0. Here it is, 1, 0. Tells me C is 1. Vertex is at the origin. That means A is 2. I go 2 this way, so the other vertex is at 4, 0. So I've basically solved the puzzle, as it were. Up and down is radical 3. So here's my equation. X minus 2 squared over 4 plus y squared over 3 equals 1. And that's about it. Okay, then the only other one I was going to do is 27. And then I'm just about done with the ellipses. Vertices are 3, 3, and 3, negative 1, passing through 2, 1. Okay. So 3, 3, 3, negative 1. That means it's bulging this way. If I go halfway between these two, so what's halfway between 3, 3, and 3, negative 1? Well, you know the x-coordinate is going to be 3. How do I find a y-coordinate? Just average them. 3 plus a negative 1 is 2. Divide that by 2 is 1. So the center is 3, 1. It's right here. Center is 3, 1. That tells me 2 up and 2 down. So automatically, if the center is 3, 1, I know I will have x minus 3 squared over something plus y minus 1 squared over something equals 1. Okay, and furthermore, let's see. I already know what? I know A is 2, which means 4 goes into here. Okay, one more time. I know it's bulging this way because that's where the 2 vertices are. A is 2, so that's going to be a 4. How do I find the B? I use the information that the point passes through 2, 1. Okay, which means put a 2 here, put a 1 here. I notice if I put a 1 here, that becomes 0, so just forget about this. 2 minus 3 is negative 1. Negative 1 squared over b squared is 1. 1 over b squared is 1. Multiply both sides by b squared. B squared is 1. B is 1. No need for plus or minus. B is understood to be positive. So x minus 3 squared over 1 plus y minus 1 squared over 4 is equal to 1. And there we go.
It really doesn't matter which like on a test which order we put x and y, right? Like if the y minus 1 squared over 4 was first, that doesn't matter, right?
It doesn't matter, and it does matter. Okay, in one sense, it doesn't matter in that they're equivalent. It does matter as a teacher. I don't want to see different students with different things, and I have to interpret them all. So you should write it with the x first and the y second, please.
Okay.
Okay, so you can think of it from that's really a selfish teacher standpoint. You know, if I know this is the answer, I want it to look like that, right? I don't want it to look like that's in front and that's second. Then I have to think about, you know, is it equivalent or not? So please have the x and then the y, which actually is a nice lead into the hyperbola. The hyperbola will have the y in front and the x second sometimes. Okay. All right, so I'm actually done with the ellipse. Okay, so I'm par for the day. We haven't even reached 9:25 on my watch yet. So I'll sneak in an introduction to the hyperbola, and then we'll probably finish very early. Okay, so I'm going to check this off. Not unless anybody wants me to do some problems in 6.3. You can go ahead and put that in the chat if you wish. But we're on to introduction to 6.4 on the hyperbola. Okay, so let me start the hyperbola now. Some things are similar, some things are different from the ellipse. 6.4 hyperbola. Okay. Here's a very formal definition of a hyperbola. You don't have to know it. Okay, but for an ellipse, page 327, the sum of the two distances from the foci are the same value. For hyperbola, the difference of the 2 points is a fixed value. Looks like we still use the word vertex and vertices and foci. Okay. So let me show you what a hyperbola looks like. Okay. We have 2 foci, 2 vertices. Okay, so this time, if you give me a set distance, let's say 10, that minus that is 10. That minus that is 10. That minus that is 10. That minus that in absolute value is 10. Okay, so we have 2 foci, 2 vertices. Our hyperbolas are of 2 types. It's either going to go left and right or up and down. Okay. So you on page 337. Okay, this is worth putting on your cheat sheet, although I'm going to add to it. Okay, this looks exactly the same as the ellipse with one exception. Instead of a plus, it's a minus. X squared over a squared minus y squared over b squared equals 1. That's a hyperbola going left and right. Okay, We're still using A for the distance from the center to vertex. We're still using C as the distance from the center to a focus. Now, for the hyperbola, we're going to write the y squared first sometimes. They're not algebraically equivalent. Y squared over a squared minus x squared over b squared equals 1. That hyperbola is going to go up and down, like so. Now we just finished talking about why don't we have the y squared first for the ellipse? Well, because addition is commutative, right? So you know if you switch them around, you do get the same thing. So what our discussion just finished on was, so the question was, can I put this in front and get something equivalent? Yes, you can, but I don't want you to make it easier for me, right? If I put this in front, a plus b is the same as b plus a. But in algebra, a minus b is not the same as b minus a. So we will have occasion to have y squared coming first. So y squared over a squared minus x squared over b squared equals 1 is going to be a hyperbola which opens up and down. So definitely put this on your cheat sheet. But there's more. I'm going to make you draw a box, and I'll show you how to make that box. Yes, question.
So on my homework, do you want me to go back and like rearrange them?
Go back and
Or
read
is it
it on the homework. Don't bother. Just,
Okay, all right,
yeah.
thanks.
For the test, well, you know what I want for the test. Okay. All right. In actuality, we're going to draw a box, and I'll show you how to do that. The text doesn't show that to you here, but the box is going to show us how to draw some asymptotes. We're back to the concept of an asymptote for hyperbolas. Okay, so I would say put these two on your cheat sheet. So big difference for hyperbola and ellipse. There's a minus. Otherwise, everything's the same. X squared, a squared, y squared, b squared. But you also have y squared over a squared minus x squared over b squared equals 1. Okay, now the number underneath the x still tells you how much you go left and right. The number underneath the y still tells you how much you go up and down. Right, that being the case, for the hyperbola, a and b do not determine the larger or the smaller number. Okay, a is going with the positive, b is going with the negative. Okay, so a might be bigger than b might be bigger than a, or they might even be equal. Okay, so the designation for a and b for the hyperbola is a goes with positive, b goes with negative. Okay, and I guess in some sense, you could say, well, that's positive and that's negative. So every positive number is bigger than every negative number, right? So you might say that's, even if that's 3 and that's a 7, there's a negative. So 3 squared is bigger than negative 7 squared, if you want to think of it that way. So in that sense, you could say still, okay, the positive is first, then it's the larger number. Okay. All right, so here's this. I would say don't write this. If you clean up the algebra, this is our familiar a squared plus b squared equals c squared, just like you first remembered the Pythagorean theorem, as it were. So standard position hyperbolas. So here are two types. X squared over a squared minus y squared over b squared equals 1. Foci are plus or minus c0. Vertices plus or minus a0. If they give you y first, y squared over a squared minus x squared over b squared equals 1. Foci are 0 plus or minus c. Vertices 0 plus or minus a. If you clean up the algebra here, it's a squared plus b squared equals c squared. And I don't know why the author decided to do this, but they're equivalent. Okay. Watch out, this is not the same formula as for the ellipse. For the ellipse, it was a squared equals b squared plus c squared. For the hyperbola, it's a squared plus b squared equals c squared. Okay. Again, if we were meeting face to face, I'd make you guys memorize these. Okay. But the way I would do it, so I digress a bit. For the hyperbola. This is for the hyperbola. Right up here. a squared equals b squared plus c squared is for the ellipse. Okay, put these on your cheat sheet. If your teacher made you memorize this, which might be for your next class, okay, my memory trick was this is a vowel, E is a vowel, right? A is a vowel, H is a consonant, so C is a consonant. I know it's kind of weird, but the vowel stands alone. E is a vowel, ellipse, A stands alone. H is a consonant, so a consonant C stands alone. So I just put down a squared, b squared, c squared, a squared, b squared, c squared, and then I think, okay, ellipse, vowel, so vowel stands alone, equals. H, hyperbola, consonant, so consonant C stands alone, a squared plus b squared equals c squared. Anyway, since you don't have to worry about it, I just thought I'd tell you what I would have done if we had met face to face and made you guys memorize this stuff. Okay. Here are the asymptotes. Okay, so you might want to have this as a box, as a part of your cheat sheet. Okay, I would say don't write these down. We're just going to use rise over the run. Okay. These 4 points were the points we would have used for the ellipse, but instead of an ellipse, you draw yourself a box. Same thing here. Draw yourself a box, connect the diagonals. They become your slant asymptotes. The hyperbola gets really, 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 really close to the asymptotes, but they don't quite touch it. Okay, so you can put these on your formula sheet. All right. And even though this is true, I would say don't bother putting it down. Okay, just do your rise over the run for the asymptotes, and I'll show you how to do that. Okay, here's an example of a hyperbola. X squared over 9 minus y squared over 16 equals 1. Center of the origin. If it's not center of the origin, it would be x minus something or y plus something or whatever. Okay, A is 3. 1, 2, 3, 1, 2, 3. B is 4. 1, 2, 3, 4, 1, 2, 3, 4. So if this was a plus, you would just simply go like that. But it's not. So instead, we draw a box. Draw the box, connect the diagonals. They're my asymptotes. Okay, since x is positive, it's going to open this way. If y were positive, it would go up and down. Okay. We can find the foci based on a squared plus b squared equals c squared. This one's easy, 3, 4, 5, right? 3 squared plus 4 squared equals 5 squared. It's like a 3, 4, 5 triangle. Okay. So foci are 5, 0, and negative 5, 0. Unlike the ellipse, for the hyperbola, C is the largest. So the foci are still going to be on the curved part. Notice that's true for the parabola, the ellipse, and the hyperbola. Okay, so for all 3 shapes, parabola, okay, if you look at a very small portion of the graph, they all look like the same, where the focus is on the inside of the curve, right? All the shapes. So, and like so. Okay.
Wait,
you
what did you
see-
say about c squared? That c is the largest for all of them?
C is the largest for the hyperbola.
Okay.
It's based on this. Okay, so you're going to be drawing stuff like this. Rather than using a formula, just use your rise over the run. You're all very good at rise over the run. That was algebra 1, right? So say 3 over 4 up, 4/3 x, and they're always going to be opposites. So this slope is 4/3, this slope is negative 4/3. Right? Rise over the run. 1, 2, 3, 1, 2, 3, 4, or 1, 2, 3 down, 1, 2, 3, 4. These slopes are going to be opposites. So the equation of the asymptotes would be y equals 4/3 x and y equals negative 4/3 x. Okay, don't put this on your cheat sheet. I don't think you need it. Okay, and besides, that's not even true for all the cases. Okay, I mean, it's a different formula depending on whether the hyperbola opens left, right, or up or down. So I would say just use your rise over the run to get it. Okay. Let me show you some homework problems and then I'll check the chat. Okay, but yeah, you'll be doing stuff like this. Whoops, more like this. Okay. Page 341. I'm not going to do the nitty-gritty details, but you'll be drawing a box, connecting the diagonals, box, diagonal, right? And then curving as the case may be. Okay, so let me show you the problems and then I'll check the chat and then I was basically going to be done. I wasn't going to do the hyperbola problems until starting tomorrow. Okay, so we had to do 1 to 20. Yeah, I'm changing to 1 to 25. So skip 7. Just 1 to 25 odd. Okay, and here they are. And while I'm showing it to you, page 342, notice they all have a minus sign somewhere, right? If this is a plus, ellipse. Minus means hyperbola. Whoops. Just in focus there. Okay, it looks like we got to do the completing the square game again. And then they tell you things like, here's the foci, here's the vertices, blah, 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 blah. Okay, so that's for the benefit of those of you who don't have the book and I'm getting it. Okay, let me check the chat on what there. Okay, can we go over 13? I'm assuming you're talking about the ellipse. 6.4. 6.3, I mean. Okay, so I'm assuming you want 6.313.
Yes, please.
This one, okay. So let's take a look at that one. Get my paper here. (6.313) 2x squared plus 4y squared plus 4x minus 16y plus 2 equals 0. Double check that I wrote it correctly. 2x squared plus 4x plus 16y. Okay. All right, so you move the 2 over. Combine these two, and factor out the common factor. So these two I can take out a 2. X squared plus 2x, leave a gap. These two take out a 4. Leave a gap. Equals -2. Okay. Quick double check inventory. 2x squared plus 4x. Yep. 4y squared minus 16y. Yep. And the 2 goes over. Okay, complete the square. Half of 2 is 2. Squared. Half of 2 is 1. Square root is 1. Plus 1, but that's really a plus 2. Half of -4 is -2. Square root is 4. Plus 4 is really a plus 16. Okay, half and square. Half of 2 is 1. 1 squared is 1. But by writing plus 1, that's really a plus 2. And here, half of -4 is -2. -2 squared is 4. But writing this, it's really a plus 16. So 2 times x plus 1 squared plus 4 times y minus 2 squared equals 16. Divide by 16, divide by 16, divide by 16. X plus 1 squared over 8 plus y minus 2 squared over 4 equals 1. Okay, so my center is -1, 2. A is square root of 8, or 2 radical 2. B is 2. A squared equals B squared plus C squared. A squared is 8. B squared is 4. So that means c squared is 4 and c is also 2. Okay, so that pretty much does it. So center is -1, 2. Okay, and square root of 8 is about 2.8 on a calculator. Okay, so my center is -1, 2. Okay, left and right is 2.8, 1, 2, almost 3. 1, 2, almost 3. Up and down is 2. Okay, so here's the center. Vertex 1, vertex 2. So I'm at -1. And I back up 2 radical 2. So -1 minus 2 radical 2, comma 2. -1 plus 2 radical 2, comma 2. And I go up 2. That gives me -1, 4. Go down -1, 0. And we don't call them anything. And foci, I move 2. 1, 2, 1, 2. So here's focus 1. That looks like it's -3, comma 2. And there's vertex 2. That looks like 1, 2. Or focus 2, rather. Focus 2 is 1, 2. And what else do they ask for? Sketch the graph, show the vertices, foci. So I think we got it. Okay. Okay, let me go back and show this to you again. You can watch the video if you need to. All right, so otherwise I think I'm done for today, folks. So tomorrow I'll start doing some hyperbola problems. Let me stop the share and see if there's anything else. Any other questions, please? Check the chat. All right, so that'll do it for today. So everybody have a good day and we'll see you next time. Okay, all right,
Thank
bye
you.
everybody. Thank you, bye.